Hoffman, and welcome to this episode of Data Exposed Live. I'm excited to have you all joining us today from wherever you're streaming from, whether it's Learn TV, YouTube, Twitch, Twitter, or via the Microsoft Reactor. Thanks so much for joining us today. We have a packed show. We're going to be talking about Azure SQL Virtual Machines. We're going to be continuing our series. We have a great series. If you haven't seen it before, go and check out our YouTube channel. But we're going to be talking today about simplifying HA and DR configurations. And for this special episode, I have two wonderful guests. The first I'm going to bring up is Rajesh. Rajesh, thanks so much for joining us today. Can you tell folks a little bit about what you do?
Thanks, Anna. Thanks for having me on the show. Hi, everyone. Good morning, good evening, wherever you're joining from. My name is Rajesh. I work as a program manager in the Azure SQL VM team, currently focusing on HADR technologies.
Awesome. It is great to have you. And we are also joined today by Pam, no stranger to the show. Thanks, Pam, for joining us on the show. Can you tell folks a little bit about what you do?
Sure. Hi, folks. I am Pam LaHood. I am the lead technical PM for SQL Server running in Azure Virtual Machine. And I work with Rajesh, and he's going to take away the show today. He's got some seriously great content on HADR, so I'm just here for color today.
Awesome. Thanks so much, both of you, and thanks to our viewers. Remember that if you have questions during the show, feel free to put them in the chat from wherever you're streaming from. We are taking a look at them, and we will be displaying some of those questions, even if you just want to say hi. So hello, Nitish. Thanks for joining us. With that being said, Rajesh, I think it would be awesome if you could start by kind of giving us a refresher. I know many people are probably familiar, but giving us a refresher on the different HADR options and what that means for SQL Server in an Azure virtual machine.
Sure, Anna. Thank you. So with that, let me get into the agenda for this session. So we have a packed agenda, as I think Anna and Pam was alluding to. We'll have three sections. The first section will talk about HADR concepts. I have one slide to just talk about HADR concepts. Then we'll do a quick overview of VM availability options. Then we'll also do a deep dive of all the HADR technologies for SQL VM space. The next section will get into the challenges with the current HADR configuration, and towards the final section, which is where the crux of this whole presentation is, we'll get into how you can simplify HADR configuration. Right. So with that, just a quick refresher on HADR. I know many of you folks who have joined this call have heard this term numerous times, but just a quick refresher. What does HA? I'm not going to read the definitions, but HA is, think of this as a scenario where you want your applications and your database be resilient to failures. Those failures could be transient, or it could be in the cloud world at a data center level or a zone level. Right? You definitely want your applications to be highly available. And disaster recovery, as the name suggests, this is in the unexpected event of some natural disaster or a catastrophic event happening where your entire primary region is wiped out. You want your applications to be up and running from a different region. That's all about DR talks about. The key message here is HA and DR are always related. We talk about them together, but they're definitely not the same, right? That's something that we all understand. And other terms which I think everybody might have already heard about it in the day-to-day world is RTO and RPO. RTO stands for recovery time objective. RPO stands for recovery point objective. The first one is all about the downtime that's incurred in the event of a event like an availability event. The RPO talks about the amount of data loss that's incurred during a availability event. And at the end of the day, every business tries to achieve stringent RTO and RPO goals. So you always have to make sure you have the SLAs for your RTO and RPO, and then you go and meet them. Right. So with that, let's get into. I also want to set the stage for what are the availability options that you have on the Azure VMs. So before we get into the SQL Server, which is running inside the Azure VMs, Azure platform in general also has a couple of availability options. And what we do within Azure SQL VMs is totally built on these platform availability options. And these may not be new to you. You might have already heard about it. I'll just spend a quick minute talking about what are availability sets and what are zones. So availability sets, they offer an SLA of 99.95%. Think of this as a logical grouping of VMs, wherein when you put a bunch of VMs in an availability set, what the Azure platform does is it spreads them across fault domains. And the way to think about fault domains is all those things which come with a single point of failure, right? Let's say all the servers which in the same rack sharing a top of rack switch, or they have the same power supply, right? And we make sure that we put the VMs in different fault domains, so that way we avoid the single point of failure. And with update domains, what we do is when a VM is assigned to an update domain, we ensure that only when planned maintenance events happen, we reboot the VMs which are in one update domain, and then we do a update domain walk to make sure that at any point in time you have availability to one of those VMs in the availability set. And availability zones, this is something that offers the highest SLA in terms of uptime. So they offer 4 nines, 99.99%. And as you can see in this picture here, it's very self-explanatory. In any of the Azure regions where availability zones are supported, you will have 3 zones, and each zone will comprise of 1 or more data centers. All these zones are physically distant, but not far enough that we also ensure that the network round trip latency is less than 2 milliseconds. So that way, within a region, you have some kind of physical separation. Each zone will have its own network, power, and cooling. So that way, you are getting the highest resilient applications that you can design on, right? And the key message, which again towards at the bottom of the slide, is for all of this to work, you definitely need to have to put a bunch of VMs, more than 2 VMs. And then it's the responsibility of the customer or the end user to make sure that there's some kind of replication going on to make sure that, hey, there is redundancy. If one VM goes down, the other VM is ready to take on the job, right? And that's where SQL technologies come into picture, which is the crux of this talk. Is we're talking about what kind of HADR technologies that SQL Server or Azure VMs have. And one message I know, which Pam has also been driving a lot in all our series, is, hey, if you think about HADR for Azure SQL VM, it's no different than on-premises. Yes, we do agree that there are some nuances that we have to deal with in Azure world, which is, again, we'll talk about in this deck. But at the end of the day, you approach it the way you would approach it in your on-premise world, right? As you see here, if you look at all the technologies that we have, it's, again, the same set of technologies. AG, which has been out from SQL 2012, always on availability groups. Then you have always on failover cluster instance, the battle tester, lock shipping, backup restore. I also listed Azure specific service, which is Azure Site Recovery. It's a fully managed PaaS service that meets all your DR requirements once you're up in Azure. Or if you also want to run in a hybrid world where, say, you have your workloads on-prem, but you still want to migrate to Azure. So you can use this Azure as a DR site using Azure Site Recovery. And if you look at the first 2 arrows here, which is in terms of RPO and RTO, what I've just done here is I'm just trying to give you a sense of, as you go down the list, both the RPO and RTO tend to go higher. And obviously, every application comes with its own needs. Some applications have stringent RPO and RTO requirements. And obviously, AG is a natural fit there. FCI is great for HA technologies. But as you go down the list, you will see that you're tending towards a higher RPO and RTO. And there is nothing wrong with it. There are applications with varied needs. Not every application needs the lowest RPO or the lowest RTO. So you definitely have to make the calculations and make sure that, hey, what's the best technology that meets the required RPO and RTO, right? And the third arrow here, which talks about, hey, is it ideal for HA and DR? This is, again, in our opinion, what we are trying to give you a sense of. AG is one of those flagship technology, which is ideal for both HA and DR. FCA is ideal for HA, and as you go down the list, you can see that Azure Site Recovery, which is, again, primarily meant for DR needs, it's something that's ideal for DR. Right.
Yeah, thanks, Rajesh. Hey, can I add just a little bit of color there? Yeah, so the one thing I wanted to talk about here, because you mentioned it's no different than on premises. The main difference between running your SQL Server solution in Azure versus on-prem is that you don't have direct control over the infrastructure. When you're running SQL Server on-prem, you have a sysadmin that's setting things up for you, like clustering, that's setting up like shared storage and things like that. When you come into Azure, you're purchasing those things as services. So the availability sets and the availability zones that Rajesh talked about, that's your way of ensuring that at least one VM in your set is going to be up. So Azure to Azure, it looks like these are all separate VMs. They don't necessarily know that they're clustered or that they're in an availability group or all that. So using these either availability sets or availability zones is one way that you tell Azure that, hey, these VMs are related, they're a set. And so I need to make sure that one is up at any given time. So that's kind of your infrastructure layer, like you would do on-prem. And then building on top of that are the SQL Server solutions. So it's not just one or the other. All of these things have to combine together to make a whole solution. And it's so the setting up of the AGs and the failover clusters, The main difference is really just configuration. Instead of setting up infrastructure, you're configuring a service in Azure. But it's important that you understand how these things all work together. And so that's what Rajesh's story is here kind of telling you, is how do we make all these things work together so that you get that same resiliency that you have on-prem.
Perfect. Yep. That's a very good way to put that, Pam. And yeah, and I think the key message here is you build on what the Azure platform already offers. It offers availability sets and zones. And then on top of it, when you're trying to look at the SQL layer, you look at these technologies and then you build on top of it. So then you establish a relationship at the platform layer, and then you get into the SQL database layer. Right. So with that, I'll quickly get into comparing availability group and FCIs. Many of this you should already be familiar, so we'll just quickly breeze through this. In terms of version, AGs have been around since 2012. FCIs have been supported for all the supported SQL Server versions out there. FCI is available there. In terms of editions, yeah, both AG and FCI support enterprise and standard. HA and DR, as I talked about, AG is ideal for HA and DR. FCI is great for HA. In fact, the other tidbit that I want to share is internally, even for our PaaS services, for SQL DB, SQL MI, when we run our PaaS services, we use availability groups in order to meet the HA and DR requirements, right? So this is something it's one of those flagship technologies which we internally use for our PaaS services as well. And the granularity, you already know that AG works at a database level, FCI is at an instance, scale limits, 100 per AG. In terms of FCI, it's an instance level. In terms of failover, AG, because you're dealing with a database level, taking out the recovery time, the failover should be less than 30 seconds. And it typically around 30 to 1 minute for an FCI because you're dealing with an instance restart, right? And obviously the advantage with AG is around you have passive, you have secondary replicas that you can use for read-only or offload your backups, which is not possible in FCI. In terms of compute cost, there are some additional compute cost that comes with AG, and this is because of the log capture thread. There is a log send thread which we spin up for each availability database. But again, this should be the overhead of this should be minimal. But in case if the system is too busy and if you put in too many databases, you might have to carefully think through what's the compute cost. In terms of storage, this is where AG and FCI differ in terms of storages. For each AG replica, you will have its own local copy of all the database files, whereas in FCI, it's a shared storage, right? You have a bunch of nodes, and then all of them talking to the same shared storage. And storage options, we have all the storage options that's out there. Whatever Azure Disk offers, we support it. So I've listed all the premium disk, ultra disk, standard SSD. This is something that's not ideally recommended for production workloads because of its all performance limitations, right? And then FCI, I'll have another slide which talk about all the storage options for FCI, but at the end of the day, you have an options around shared disk, premium files, and storage space direct, right? In terms of licensing benefit, yeah, if you have an SA benefit, you get a passive HA and a passive DR replica, right? So with that, for the availability groups, right? If you ask us, hey, how do we create availability groups? One of the key message that I know Pam also did a session on is around the value prop for SQL Server IaaS agent extension, right? So this is a free extension that we offer for customers, and our main intention is to help you automate all the administrative or management tasks. And it also does availability group creation as well. So it does creation of clusters, it does creation of group, it also does creation of availability listeners. So once you have the extension installed, you can use the PowerShell, and then you pretty much think of an agent which is running on those VMs, and then you invoke the PowerShell or CLA commands, and then you leverage IaaS extension to do work on your behalf. So that way, it takes the administrative overhead of logging into each of those VMs and setting all of this up. So all of this is done automatically for you. And there's also other way where you can say, hey, you can also do it manually, which is, again, many customers do it. As we have seen in big enterprises, they have their own golden images, they have their own processes and standard operating procedures that they follow. So that's how we have seen customers do it as well. And in terms of connection, which you already be aware of, is there are two options. One is the virtual network name, referred to as VNN. And then in the recent past, we also introduced a DNN option for connecting to availability groups. The reason why I put a star is it does come with limitations in terms of it has some requirements around unique port. DNN is a concept that's been around in the Windows world. What we did for availability group is we leveraged the same concept and said, hey, can that be used for availability group? And that's what we came up with. But it does come with limitations in terms of requirement for unique port, inability to use port 1433, which is again default port. There are some feature interoperability issues which you'll have to think through when you're dealing with a large surface area of SQL Server. And then there is also a coexistence of DNN with VNN for FCI scenario. So which kind of makes it a scenario where, hey, before you get into DNN approach, you still have to carefully weigh in options. Are you fine with all the limitations, right? And then the next slide, what we do is let's quickly compare all the storage options for Azure SQL VMs for the FCI scenarios. This is one area where we have been asked so many questions in the past in terms of, hey, there are a bunch of options out there. Is there one option that Microsoft can recommend in terms of the storage solution for Azure VMs, right? Great. I mean, we have a bunch of options. As the platform has evolved, we have come up with options in terms of, we started with S2D, which is towards the bottom, which is towards the far right corner. Then we introduced premium file share. And recently we introduced Azure Side Disk. So Azure Side Disk has been available in all the Azure regions. And if you think about it, if you ask us, hey, what's the recommended storage solution for FCIs? Our recommendation is to go with Azure Side Disk. So this is an on-premises equivalent for your SAN storage, the block storage that you get on-prem with the same iSCSI, this SCSI protocol that you had on-prem. We pretty much have the same technology that's been around in on-prem. We have brought that into the Azure world in terms of a shared disk. So, which essentially means if you have an FCA on-prem and if you want to lift and shift or you want to migrate them to Azure as is, the best option is to go with shared disk, right? And as you can see, it scores well on all the dimensions that we are looking at. Like, there's no minimum OS version. There's no minimum SQL version. It also supports VM availability with highest resiliency, because when you put VMs in availability zones, you can leverage the premium SSD zone resonant storage, which gets you into a position where you can put all the FCI nodes in separate zones and then create an FCI on top of it, so giving you an SLA of 99.99%. On the other hand, if you also have other set of customers who say, hey, I want to have the lowest latency between these FCI nodes, is that possible? So that's also possible. What you could do is you could put them in an availability set and put them in a PPG, which stands for Proximity Placement Group. What it does is it makes sure that all the VMs are co-located within the same data center, giving you the lowest latency possible. Obviously, it does come with a lower SLA, but still you get a 3.9 SLA, right? And then the last option in terms of VM availability with moderate resiliency and latency. And the reason why I say moderate is there are some applications who might need the lowest single-digit latency for read and write for disk, or even sub-millisecond latency on the disk side. So if you want to leverage the ultra disk for those scenarios, you'll have to put all the VMs in a single availability zone, which does reduce the SLA. But still, if you have a requirement for the lowest sub-millisecond latency, then this is an option that you can go with, right? And it doesn't have any limitations on on SQL Server feature side. Premium file share did have some limitations in terms of the feature parity. So shared disk definitely checks this box. You can still storage pool. You can create a bunch of VMs, a bunch of disks, and then stripe the disk, and then create a bigger storage pool that you want. And the biggest advantage is Azure Side Disk doesn't use the VM's network bandwidth, because if you think about it, in the S2D and the premium file shares, they were using the VM's network bandwidth, unlike the storage bandwidth, right? But in terms of shared disk, we typically have a set bandwidth that's set aside for storage traffic, and then you also have a dedicated network bandwidth. So we don't use any of that network bandwidth for all the storage traffic. One thing where shared disk doesn't still need to evolve is on the blob cache, which is something that we have it in our backlog, and we might see this anytime soon. Right.
Rajesh, I just wanted
sure.
to comment, like, this has been really useful to get kind of an overview of not only like the different HADR options for SQL Server, but how that relates to Azure virtual machines and all the different options you have. And it sounds wonderful, but I know it's more complicated than this, right?
True. Yeah, it is. I mean, we have seen customers, and we'll be very. We have seen customers with feedback coming in loud and clear as, hey, there are a bunch of options. Give us some prescriptive guidance on what needs to happen, and this is our effort to make this better. We are going with, like, if you think about AG scenarios, we are coming up with newer ways of making it where we take away the administrative and management tasks for you on the AG side of things. We're also thinking what can be done for the FCI. In terms of storage story for the FCI, this is one area where we have We have done some recent improvements in terms of going through shared disk validations. We have made sure that shared disk checks the box on all the sites on the SQL side. And this is our effort wherein we are trying to pass the message to you saying, hey, if you look for a recommended approach on the FCI storage, go with shared disk, because that's something it's an on-premise equivalent of SAN storage. So if you have an FCA on-prem and you want to lift it Azure as is, the best way is to pick up Azure Shared Disk.
Awesome, cool. Thanks, Rajesh. This is really useful. And I know we're going to talk about some of the other challenges and more of your guidance, which I think is always really useful for me and our viewers.
Got it. Yep. Thank you. With that, let's jump right into the second section, which is where I'll just set the context of what are the current challenges with the HDR configuration, right? Obviously, there are two options, availability groups and FCI. But if you look at what customers are dealing with today in terms of setting up AG on the Azure platform, for both AG Listener and FCI, you definitely need Azure Load Balancer. The diagram here has been copied from the Azure docs, and ILB here stands for Internal Load Balancer, which is again the same term for the Azure Load Balancer, right? And even for Windows clusters, when you start building Windows clusters, Windows cluster definitely needs an IP. This is for Windows 2016 and below. You again need a load balancer IP if you want to put the cluster IP on the load balancer, right? For 2019, things are better because you can leverage the DNN concept for building Windows clusters, because what it does is it binds the IP on all the nodes. You will have a dedicated IP, and then what DNN does, which is a distributed network name, it binds to all the IPs of the nodes, and that's how it doesn't have a requirement for the Windows cluster IP to have it on a load balancer. But nevertheless, if you're dealing with 2016, you still have to deal with a load balance for the Windows cluster, right? And in multi-region setup, which we have seen customers come up with because they have a primary region in one Azure region, and then they pick a different Azure region for DR, you have to deal with a load balancer on both sides, right? So you need to have a load balancer on primary, you need to have a load balancer on the secondary region. And all of this, if you ask us, hey, why do we even have to deal with Azure Load Balancer, which is a pure networking concept, and why do we have to deal with in the SQL world, especially on the HADR technologies? And the reason is, I'll quickly touch upon some of these concepts. I know if you have heard about it in the past, it might be something that you have already heard about it, but let me just quickly set the context of why you need load balancer in the Azure world. Right. In the public cloud, and this is not specific to Azure, you pick any public cloud, the ARP protocol, which does the mapping between the VM IP address and the MAC address, that's something that's disabled because of the software-defined networking architecture, right? Imagine the fleet of servers that we have to manage, so it's impossible to have all those route table entries available in a public cloud. And the AG listener name or the FCI network name, if you think about it, both of them are a DNS network name, right? And for a DNS network name to come online, you need an IP address, which means you need to have an IP address that can float between your replicas or nodes, depending on who is the primary, right? And this is something, it's not new. It's been there in on-prem world. Customers have configured it that way. And the traditional floating IP, which is easily achieved in on-prem world, is not possible in public cloud because we don't have an ARP way, right? And the only way that we could have done it, and we are able to do it in the Azure world, is through a load balancer. Because if you look at the screenshot here, the one that I've highlighted, load balancer has a property called floating IP. And once you enable that, all it does is, instead of exposing the VM's private IP, it exposes the load balancer's front-end IP configuration, which in a way is a neat way to get, say, a floating IP functionality in the Azure world. So instead of worrying about, hey, how do I have an IP which is bound to node 1 and then bound to node 2, what you do is you bring in load balancer, you have a load balancer IP, and then you make the load balancer IP route the traffic depending on who the primary is. And that's pretty much been the preferred way. In fact, our documentation always says that, hey, if you are trying to create availability groups or FCI within a single subnet, then go with load balancer because it doesn't have any limitations. The other recent approach where we invested is on DNN, which I just talked about, but it does come with certain limitations, right? And some of the challenges that we have heard with load balancer, and this is, I mean, many of you might exactly closely relate with what I'm trying to explain here in terms of what load balancer brings in us, it's complex to set up. This is a networking component that customers have to deal with. It's not easy to configure, and it's also not easy to maintain. There are lots of moving parts in terms of the ones that I've listed around front-end IP. You have to deal with backend pools. You have to worry about health probes, setting up the health probes, and then you have to tie all of them together through a load balancer, which tells you, hey, if a packet arrives in the load balancer IP on so-and-so port, route it to the backend pool on so-and-so port, and then you define the health probe. So this is not something that's easy to maintain, easy to set up, right? So we have seen this complexity that customers are dealing with. And the other feedback that we have also heard is, because there is a health probe, and the lowest health probe that you can go through is around 10 seconds, which means you need at least 2 health probes to fail, and think of them as heartbeat, and these heartbeats run at 5-second intervals. So which means you need at least 10 seconds for the health probe to detect, say, hey, node 1 is down. Now I have to route the traffic to node 2. And this takes at least 10 seconds. This is over and above the time that it takes for all the failover, the recovery process that happens during a failover, right? And this was something that customers were not happy with, saying, hey, this is a latency that's been induced because of the load balancer component, right? And with all of this, what we wanted to now do is we'll get into this next section of where we explain you in detail of how you can simplify all of this configuration and how you can address all the challenges, right? So this is all about what we can do is you bring in multi-subnet into the picture. So what multi-subnet does, which is, again, we are very excited to show this to the entire world, is around in a multi-subnet configuration. What you do is you place each replica in case of an AG, or each node in case of FCI, in a separate subnet range, right? And these subnets could be all within a virtual network in one region, which is a typical HS scenario that customers deploy. Or they could be in different virtual networks. Like if you're dealing with 2 Azure regions, as we just talked about earlier, which is, again, suited for DR scenarios, you could also have these different subnets in different Azure regions, right? And once you have this, what SQL Server does is, and which has already been out there, SQL Server has been natively supporting multi-subnet for both AG and FCI. So this has been happening in on-prem world, right? If you think about it, in the on-prem world, you have site A and site B, where site A used to be your primary site, and site B used to be your DR site. And both of them definitely had a different subnet range. So we supported subnet right from the on-prem world. And once you have the VMs in a different subnet, one of the prerequisite for the multi-subnet to shine is we heavily rely on secondary IP for the VMs. And if you're wondering, hey, what does a secondary IP actually look like, and what is a secondary IP? In addition to a primary IP, let's say when you go to the Azure portal and start creating an Azure VM, you get a private IP, which is your primary IP, as you can see in the screenshot here. And we'll also get to a quick demo as well. And then you go and create additional IPs, as in this case, I'm looking at 2 VMs, SQL VM1. And what I've done is I've created an IP for the Windows cluster. These are in different subnet ranges. As you can see, the prefix is 10.38.1. So I have an IP for the Windows cluster. I have an IP for the listener. And then for the SQL VM2 down in the bottom, I've done the same thing for the second VM. And the difference in both of them is they're in different subnet ranges. The first one is 10.38.1. And then this one is 10.38.2, and then I have this ending with .10 for cluster, and then .11 for listener. So once you have the secondary IPs created, it just works out of the box, wherein you can create cluster, and then you can also create AG without any issues. And what secondary IP does is, and if you ask us, hey, how does secondary IP solve that floating IP challenge that we just talked about, right? And what secondary IP does is, once you have created secondary IPs for these VMs, you no longer have to deal with the traditional floating IP requirement. What we do is we natively leverage the OR dependency for the cluster IP. We do the same thing for the AG listener. We also do the same thing for FCI. And this is how it looks like. Like if you look at the cluster resources, you can see that the cluster network name has an OR dependency between these 2 IPs. And each one of them belongs to the 2 nodes, and both of them are in different subnets. So you can have an OR dependency. One of them will be online depending on who owns the resources. The other one will be offline, right? And this extends naturally to AG listener name as well. As you can see, in case of AG listener, you have 2 IPs, 1.11 and 2.11. the listener name, which is AG1 listener, binds naturally to both these IPs. And it also looks the same way in the Failover cluster manager as well. And we'll get to a quick demo where I'll show all of this in action. And same thing for the FCI too. What we do is when we build a SQL FCI and you specify the network name, we detect that, hey, the VMs are in different subnets. So the FCI setup knows that, hey, these are two IPs that I need to get binded to. And then for the network name to come online, one of them needs to come online. And that's pretty much it in terms of what it does to simplify all this configuration. So let's
Rajesh,
quickly...
before we get into a demo, I just want to
Sure.
ask probably a dumb question, but I'm going to ask it anyways. Two questions. The first question is, this secondary IP concept, is this going to enable us to not need an Azure Load Balancer?
Yes, that's exactly the key message here is, once you embark on this multi-subnet and secondary IP route, you no longer have to deal with load balancers. So gone are the days where you have to deal with load balancer complexity, trying to figure out, hey, what that load balancer is all about, then set it up, then try to maintain it. And the biggest challenge that we've also seen customers is during the failover and failback instances, we also saw many support cases where customers were struggling. Hey, the traffic doesn't route to primary after failover. There's something going wrong, which we're not able to understand. So all of that is out of the way once you embark on this multi-subnet and secondary IP route.
Awesome, cool. Okay, so that's actually really exciting then, because you can avoid all these challenges. Then the other question I had about secondary IPs is, if I'm using these secondary IPs for the FCI or the AG listener, are they reserved?
Yes, that's a great question. So as you saw in the screenshot, which I'll also show in the demo, is once you define the secondary IP on the VM, we actually have a record for it in the Azure control plane, which means the network resource provider, which is the network control plane, has an entry saying, hey, this is an IP that's been assigned to the assigned to a VM, particular VM. So which means there is a connected device for that IP. So any other device in the network or in the subnet cannot have that IP. So you definitely are falling into that reserved nature, which is what many customers want, because they don't want any IP conflict or any other issues that might happen if the IP is not reserved, right? So yes, the IP is reserved.
Okay, awesome. Thanks so much.
Perfect.
Let's see the demo.
All right, perfect. So let's get into the demo part. So it's a quick demo. What I'm going to show you is, hey, how does a secondary IP look like? How do you create, and how does this even, how do you go and find it out? So I have two VMs, SQL VM1. And what I do is, if you click on the networking tab, and then if you click on the network interface card, in this case, clicked on this network interface card, and then you see a bunch of IP configurations, right? And the first IP configuration that you see is the VM's own IP, which is the 10.38.1.4. And then what you do is we go ahead and we added these two secondary IPs. And I can quickly walk you through how you add a secondary IP. Let's say in this case, let's give it a name to the secondary IP. Let's call it AG listener test. And by default, since you already have a primary, any IP that you add will always be secondary. And then allocation, let's choose a static, which is what we want. Let's give it a IP that follows the sequence. I already have 1.10, 1.11, so I've given 1.12, and then I click OK, and that's pretty much it in order to create a secondary IP. This is an online operation. As I just mentioned, this is a control plane only operation. We only make sure that we record this information on the VM's network card. Pretty much that's it. So as you can see here, this was instantaneous. We just have this IP on the network interface card. And what I've done for the other VM is I've done the same thing. I've went into the network interface card, clicked on IP configurations, added a couple of secondary IPs for this VM as well, because both of these VMs are in different subnets, right? That's pretty much about the demo part. So let me quickly walk you through back into the architecture. I want to show you a quick architecture, a typical HA architecture, and then get into show the other things in action, right? So if you think about the entire multi-subnet configuration, what are the steps involved if I have to go over and embark on this multi-subnet approach? The first step, you create VMs in separate subnets, which I'll show you in a quick architecture diagram. Once you create the VMs in separate subnets, then you add secondary IPs, which we just saw. We add one IP for the cluster. We have another IP for the listener, as we just saw in the demo. Once you do that, then you start creating your Windows cluster. You set the cluster IP. Then you start creating your listener and SQL FCI. And all of this will naturally flow because you don't have to deal with any load balancer at all. The setup already knows that, hey, you're dealing with multi-subnet configuration. AG listener automatically detects that, hey, I'm dealing with 2 VMs which are in multi-subnet, and there you go. You get everything right out of the box. And the last step, like if you're trying to connect, the connection string needs to have multi-subnet failover. It's not big of a requirement for the newer clients. Like if you have anything above .NET 4.6.1, this is something that's already out there. But if there are some older clients which don't support the multi-subnet failover switch, we also have some workarounds in terms of setting the register all IP providers to 0, and then setting a lower host TTL record. So this is something that's already known to many customers, right? Let's quickly get into the architecture diagram, and then I'll get into the demo part of showing all of this in action, right? So what we have here. So we have a region. I'm starting with one Azure region. It has a 1038 virtual network that I've created in this region. And then I have 2 zones, availability zone 1, availability zone 2. And what I've done on top of that is I've created 2 subnets, SQL subnet 1 and SQL subnet 2. And once I've laid out this, carved out the subnets, I'm good to go to create VMs, right? So I've created 2 VMs, SQL VM1 and VM2, both of them in its own subnet. And then as we just saw, we added, each of them comes with their own private IP, which is the primary one. And then we added a couple of secondary IPs. Once you do all of this, then you can pretty much go and set up the Windows cluster. The cluster already detects all of this, saying, hey, this is in a multi-subnet configuration, AG. And then when you start creating an AG listener, the listener already knows that, hey, I'm dealing with 2 VMs which are in different subnets. So that way, the listener just comes online without any of this. So as you can see here, the key message which we again want to drive across is you don't have to deal with any load balancer here in order to route the traffic. So which addresses pretty much all the challenges that customers have been facing today, right? So with that, let's get into a quick demo. I'll show a bunch of things in terms of the cluster, AG resources, and a few other things. So let me quickly get into my demo machine.
Awesome. This is really cool, by the way. Like, I'm excited to see this and excited to hear how this is going to alleviate a lot of customers' challenges with load balancers.
Yeah, we are excited too. I think we have had these conversations. I think Pam and we were discussing about it earlier, like what can we do to help alleviate customers' pain point, what can be done, and this is something that we are very excited to show this to the entire world. All right, so with that, here I am in the Failover Cluster Manager. I hope you guys can see it. I can zoom in when I get into some properties if it's not visible. But let's say I've started the cluster. So this is a Windows Server cluster. Let me quickly show you 2 nodes. I have 2 nodes, VM1 and VM2. If you look at the network, like the cluster natively detects the networks, right? As you can see here, this exactly knows that, hey, I am dealing with 1038 1.0 series. And then if I look at the second network, because the cluster knows that, hey, in this case, I'm dealing with 2 VMs and they're all in different subnets. So this is what I meant by having that native support from Windows cluster and the SQL world, right? So once I have this, then I created the cluster. And as you can see here, you can have the cluster resources dependent on or dependency with those 2 IPs. And this is something that's evident if you look at the properties. And then if you check at the dependencies tab, you can see that, hey, I have this odd dependency, which is, again, the key thing in a multi-subnet configuration, right? And then if I get into the SQL AG listener part, right? I have the SQL AG listener, AG resource, and then it also has a listener part. And similar to what we have seen for the cluster world, you can see that, hey, in the dependencies, it's pretty much the same. I have the odd dependency between these 2 IPs, right? And then if I quickly get into the SSMS world, I've connected to 2 VMs, so VM1 and VM2. And then VM1 is my primary. This is where I've created an availability group. And then I also have an availability group listener. If I get into the properties, and as you can see here, for the listener name to come online, it pretty much knows that, hey, I'm dealing with 2 VMs. They're in different subnets. And these are the IPs that I'm dealing with. So 1.11 is on VM1. 2.11 is on VM2. So with that, I know that, hey, I have this multi-subnet configuration that I have to deal with, right? So with that, let's do a quick test. So let's get into a client VM. Let's say I have a different VM, which is outside the AG. And this is how you test the connectivity, right? So let me connect to the same, the availability group through a listener name. If it's not visible, it's AG1-listener, the same listener that we just connected through. And let's go ahead and quickly run, check what's the primary at this point in time, right? So let me run the select at name. just to see where I'm connected to, right? I'm connected to VM1, all right? Now let's go ahead and do a failover. And this is what customers do in the event of a planned maintenance, or if there's an unplanned event, which is where the HA has already been set up, right? So let's go and do a quick failover. I want to connect to SQL VM2. Let me authenticate. And then I hit finish. So while this is happening, let's see if we can quickly catch what's happening here as well. So as you can see here, in a flash of a second, we just saw that 1.1, which was the first VM's IP that went offline, and now the second node, which is SQL VM2, the IP came online, and so as in the listener came online, and then all the other resources just come online too, right? Now let's quickly get into the app VM and then see if we can reconnect and then run the same command again to see where we are connected now. And there you go, you're connected to SQL VM2. As you can see here, this happened probably in less than 10 seconds. We quickly switched, hopped back into this VM. There's no additional latency, nothing that you typically had to deal with in terms of the load balancer. All of this just works natively out of the box, right? So with that, let me get back into.
That's awesome. A quick question while you're switching around. Is there a cost associated to kind of running these secondary IPs?
That's a great question, Anna. In fact, there is no cost. So similar to private IPs, you can have any number of secondary IPs. Of course, there is a limit. The limit is 256, which is again a soft limit. And we think that there's never a scenario where you have to exceed more than 256. But if you need, then you can always call in the support and get the limit bumped up. In terms of cost, there's no additional cost. Only if you start assigning a public IP, which again has a nominal charge, which is something that customers do even today, right? If you need a public IP, you definitely have to pay a nominal cost. Other than the public IP, if you don't have a requirement to have a public IP for the secondary IP, there's absolutely no cost. All of this comes for free.
Awesome. That's awesome. We also had one quick question from the audience that just wanted to boil up. I think this viewer is more familiar with Azure SQL database concepts. And one thing they were saying is like, is the end result here when you were going about setting up this availability group similar to a failover group that you would get in, say, Azure SQL DB?
Yes, that's exactly what it is. And I think I did touch upon this point earlier, as even for our PaaS services, we go ahead and we leverage availability groups under the hood. That's how we meet our HA and DR requirements for all our flagship PaaS services, be it SQL DB or be it managed instance. So that's pretty much what we use underneath the covers.
Awesome, thanks.
All right. With that, let me quickly show you other architecture diagrams. I mean, as we started with the simplest example where we had HA, but there are customers who come in with complex HA and DR topologies, right? And we said, hey, we wanted to test multi-subnet in every scenario. And we'll walk through a few scenarios where we see, hey, multi-subnet, where it just works out of the box, right? So what we're dealing here with is an HA and DR scenario. So you have two regions, West US 2 and Central US. And in region 1, you pretty much had what you had for the HA, 2 zones, a couple of VMs, and then you have created the secondary IPs, and then you create the third VM in a different region, because here you're dealing with a DR, right? It comes in a different region, so obviously it has a different address range, so which is a natural fit for the multi-subnet scenario. So now with all the 3 VMs, you go ahead and create the Windows cluster part, which just works out of the box, and then you go and create availability group, and the listener, everything just works seamlessly.
Wow.
So gone are the complexity where you had to deal with a load balancer on region 1, load balancer on region 2, because you just double the complexity with load balancer, right? You add one more load balancer, it brings in, it adds up all the complexity that you had to deal with one more, right? So all of that is gone. Everything just works out of the box here. Right. With that, we'll get into one more architecture. This is again for those kind of customers who want to go much deeper into AG world. This is exploring 2 regions. Again, we're dealing with 2 regions, but what we are now dealing with is DAG, which stands for availability group. And the way for customers, if somebody who doesn't know what DAG stands for, it's an availability group of availability group. And what you can see here is I have 2 separate regions. And in each of those regions, I have the similar setup. I have 2 VMs in separate subnets. In a different region, I also have 2 VMs in separate subnets. But what I do here is I create a cluster 1 on region 1. I create an availability group on region 1. Again, in multi-subnet, everything just works with a load balancer. Then I hop onto the secondary region, and what I do is I create a Windows cluster, different cluster, and then I create a different availability group. And then on top of that, I create a DAG, which is a distributed availability group. And what it essentially does is it routes the traffic, which it makes sure that data is synchronized between the primary on your region 1, which is again called the global primary, to the forwarder. And then the forwarder makes sure that it routes or sends the data to its own secondaries in a different region. Think of this as layered availability groups. It's not common, but there are scenarios where DAG fits in neatly in terms of HADR or migration scenarios, because customers want to have a DR setup where they don't want to have the cluster nodes in DR to be part of the same cluster as in primary. So if you have those kind of requirements, these are geographically dispersed far off, and then you want to have these discrete clusters, availability groups, and then have a availability group on top of it. Multi-subnet just works out of the box even in this scenario as well.
Wow, that's really exciting. We have a few questions that have come in. If you have a second, I just wanted to ask. One is coming from Javier. He says, when you fail over an AG from one VM to another using DNN, does the client traffic or connections redirect to the new primary right away? Is it the same as in a VNN?
Yeah, that's a great question. Yes, that's a great question, because even the reason why we invested in the DNN is again to avoid load balancer. DNN was one of the solution that we came up with in saying, hey, here's an approach where with the DNN you don't have to again deal with load balancer. It does solve the complexity of not having load balancer in the equation, not having to deal with all the failover latency that the DNN introduced, that load balancer introduced, right? But the few things that are just highlighted in the slide is DNN does come in with certain limitations. We have also seen some user feedback wherein customers say, hey, setting up DNN, I don't have any UI method. It doesn't seem like for FCI scenarios, DNN is not well integrated into the setup process. I still need to have VNN, then I need to have DNN. So it was a solution that we came up with, but it still has its own limitations. It still does come up with some the customer experience as well. So those are the things that DNN currently has. But Javier is exactly right that with DNN, even the connectivity just works, right? I mean, without a load balancer, the failover, everything is seamless. And I also have a slide towards the end of this deck where I compare all the solutions that we currently out there, and
Awesome.
How multi-subnet shines across all the dimensions. Right. With that, I think we're doing good on time. So let me quickly touch on the FCA part. So now we talked about different configurations for AG. We started with an HA scenario, then we added a DR scenario. We also added a DAG scenario. Like all of that works with multi-subnet. Now, if you're wondering what about FCI, it's the same story. Everything works out of the box. Here I have an FCI, and this is a special FCI. I call it a zone redundant because it uses the premium SSD ZRS storage, which is again industry leading. No other complete cloud has it in terms of having a shared disk, which is again zone redundant, right? So what I have here is I have two VMs, both of them in separate zones, which is what I want if I want and adopt a highly resilient architecture, right? And then I do the same thing. I have the primary IPs, I add a bunch of secondary IPs, and then I created a shared disk, and then I go about creating cluster, FCI, everything works out of the box. I'll quickly show this in a demo, unless, Anna, if there are any questions in the
there is one question while you set up. Maybe you can answer it. This was about the distributed availability group. This question was from Justin. He basically said, like, what would be a reason for this to suddenly fall behind if it was working for a while running on Azure SQL VMs?
I didn't quite get the question, Justin, in terms of falling behind. If it's around the data synchronization, I don't know if you're alluding to data synchronization. If you can elaborate on that, then I'll probably be in a better place to answer that question.
We'll see if he gives more details. Let's see the demo.
All right, perfect. So with that, I'm showing two VMs here, SQL VM5 and then I have other VM. So these are the two VMs that have been used for the FCI. The one cool thing that I wanted to show you, which is again we are very excited, is the shared disk part, right? So I'm in the VM. I clicked on disk. I'll click on the disk here, and this is a shared disk. I've named it shared disk, but if you don't believe me, what I've done here is it has a max shares of 4. So this is what I meant by, hey, this is a special shared disk wherein it's one of those industry, first in the industry technology that we say, hey, this is one of those shared disks where you have a disk that's shared across 4 VMs. And this you can do it while you're creating it. The other key message which I also want to highlight is the zone redundant storage part, which again ensures that you can have the FCI nodes in different zones, which is again what we have done. Once I have used this ZRS storage, I can have VMs in different zones and then still talk to the zone redundant storage, right? And then as you can see here, the shared disk is managed by 2 VMs, SQL VM5 and SQL VM6. And if you want to quickly check about the zones, let me show that as well. Like you can see that this is in zone 1, which is what I was alluding to. And then if you look at VM6, this is in zone 2, right? And each of them are in separate zones. Both of them have the same shared disk. As you can see here, it's the same disk. And it exactly shows that, hey, this is being managed by VM5 and VM6. So there you go. You have a shared disk in a zone redundant fashion. And then you can have the VMs in zone redundant in multiple zones and then have the shared disk across them. Right. So with that, let me get into the demo part. I'll show this FCI. We'll also do a quick failover and see how things work. Right. So here I am in the Windows. I'm in one of those VMs, and then similar to what we saw in the AG world, right? I mean, on the Windows side, on the Windows cluster side, everything is exactly the same. So you have the same OR dependency, pretty much exactly the same. But by now you have pretty much got the concept, right? I mean, with OR dependency, we create the cluster, right? That's about it. If you explore on the FCA part, which is where we want to get into, right? So in this case, again, the same concept. Like when you try to create the FCI, you get into that OR dependency approach. And then I'll also show some screenshots of how this looks like during the setup. And then when you use the OR dependency, you have these 2 IPs dedicated for FCI, and both of them comes online, right? Pretty much everything works. And then let's quickly go to SSMS and see if we can connect to it. Right, let me. Right, so currently I'm in connected. That's the network name that I connect. Unlike AG, you will always connect to the same network name, right? So let's go ahead and do a failover. Let's move this resources. It's currently on VM5, as you can see here, and let's move it to VM6. So let me move it to VM6. And as you see the failover going on, as I move the resources, you can see the IP that went offline here came back. It's coming up online on 2.21. And pretty much with that, it brings in everything. So it brings in the network name. Once the network name comes online, you will see SQL Server coming online, and then the other services like agent and then the CIP telemetry, right? There you go. So you saw the the FCA coming up, moving from VM5 to VM6. And if I go to the client and then quickly run it again, there you go. I'm still connected. FCA with the same network name. I still have the same name, right? So with that, what we have seen is we have been able to test both the AG, as we saw in the earlier demo, and now in this demo, what we have seen is the failovers of FCI in a multi-subnet scenario, and all of this just works right out of the box.
Awesome. That is super cool. Thanks for sharing with us. One quick question I had is like, is there any like performance considerations people should take into account when they're going about setting these things up?
Good. That's a good question. In the Azure world, I mean, in the software-defined networking world, if you ask us, hey, are there any perf impacts if I am dealing with a multi-subnet, which is a valid concern? And the answer to that is it's simply no, because all of this is logical, right? When you create a virtual network, you just go to the portal, you create a virtual network, and in less than 10 seconds, you get a virtual network, right? If you imagine that what you have been doing what you had to do in on-prem, somebody has to go physically run cables and then do it, right? So comparing and contrasting with what you had to do on-prem, what you do in the cloud world, everything is logical, right? Behind the scenes, we have the physical resources, but as a customer, you deal with all the logical constructs of, say, I have my virtual network. And within the virtual network, I'm carving out subnets, which is, again, a logical concept. You set aside an address range for subnet 1. You set aside a address range for subnet 2. And at the end of the day, when traffic gets routed to subnet 1 or subnet 2, it is, again, the route tables, right? We already know what the destination packet, we already know the destination IP where we have to route the packet to. And NRP, which is the network resource provider of Azure, does the magic for you. And this happens in every public cloud, right? So essentially, there are no perf impacts if you have to deal with multi-subnet in the public cloud world. So that's the neat advantage of having multi-cloud or the multi-subnet approach.
Awesome. Thanks, Rajesh. And we got one more question from our viewers. Sai says, what's the best option for considering FCIs across multi-region in terms of storage? Shared disk, premium, S2D?
That's a great question. So as we talked about FCI, FCI is great for HA scenario. And the reason why we say it's great for HA scenario is you have a storage that's shared across the nodes, right? Now, if you try to bring in a different region, the obvious thing that you have to worry about is, hey, how do I replicate my storage from region 1 into region 2? That's where things get complicated in an FCI scenario, because no customer would want to have a stretch FCI spanning across regions. And what we have seen, which is again a proven architecture, is if you have a requirement where you need to have FCI for your HA reasons, go with FCI. Pick any of the storage options that we just talked about. We again recommend shared disk. And then if you come into a scenario where, what about DR? For DR, you can go with AG. So that's a natural solution where you say, I have my FCA for HA needs for the primary region. And then for my DR needs, I go with a availability group, which is again a natural fit because it does the replication, storage replication. You don't have to deal with a shared storage if you're dealing with AG, because each replica has its own local storage. So you'll have AG built on top of FCI for your DR needs. So that's again an architecture that we have seen customers adopt.
Awesome, cool, thanks.
Perfect.
Hopefully that was helpful, Sai. As we look to start to wrap up this episode, I'd love if you could just kind of recap and let us know what is this multi-subnet thing doing, and when should we use it, and how do we compare it?
Perfect. That's a good segue to the final 2 slides that I have. So what we are trying to do here is we're trying to make it simple in terms of, hey, with all the available options, where are we, right? And what is the recommended next steps, right? In terms of saying, hey, what are my next steps? So if you have a scenario where the VMs are in separate subnets, go with multi-subnet. This is the most recommended approach. As you saw, SQL Server natively supports it. Setup is easy, maintenance is easy. It doesn't have any kind of limitations as DNN has, and there's no failover latency, right? And versus if you look at what DNN had, it has some kind of limitations. So if you're fine with the limitations, go with it. If not, then the best approach is go with multi-subnet. And then for load balancer, which is where both the complexity, it has the complexity and it also has the failover latency. So that way, it gives you a good way of comparing, hey, with all the options that I have, how do I go about next, right? So this is one of those things where you can say, hey, go with multi-subnet if you have VMs in different subnets. And with that, we also have some docs. So these docs will be published very soon. We will have prescriptive guidance on how to create availability group, how to create FCA. So all the things that I showed in the demo will show you a prescriptive step-by-step instructions on how to set up all of this.
Awesome. Right. So for our viewers, just follow our YouTube channel so you can get these links. We'll put them into the description once they're posted. One related question, it seems like the docs for this is very new. I probably should have asked this up front. Is this brand new technology, this multi-subnet, and is it in public preview? Is it generally available? What's the status?
That's a good question. So we have vetted this with SQL engineering team. We also vetted this with our Azure networking engineering team, and we have done all kinds of testing and validation. So we are going to generally we are going to make it generally available pretty soon. So once this is out, it will come in with a GA tag, so which means you can go ahead and start deploying multi-subnet approach because it's already been out there in the on-prem world for quite a long time. There's nothing that SQL on the SQL Server side that you have to do. Because as you saw in all the demos, everything just works out of the box. Right. Both Windows cluster and SQL engine natively supports multi-subnet. So when we have all of these docs out, as we will post it in the video, you can go ahead and start deploying that in your production environments. Absolutely no concerns at all.
Awesome, great.
All right. So with that, one quick slide, which is again, hey, if I'm currently on a single subnet, what do I do? We'll have this documentation as well. We'll have prescriptive guidance, as you see here, the bunch of steps that you have to do if you have to move from AG. Let's say I'm in a single subnet dealing with load balancer, but I want to move away from it. So you will have these steps as well. And these are pretty much, you might have to deal with one reboot when you change the subnet, but that's pretty much it. We'll have all of this up in the docs as well. And I can also quickly show you how the docs look like. These are the docs that we are talking about. So you will have prescriptive guidance in terms of the architecture that you build. So when you create, configure SQL VMs, you will see the secondary IPs, prescriptive guidance on how do you add secondary IPs. And then once you have the underlying VM setup, We'll walk you through how to create the cluster. You'll have the cluster configurations. We'll show you, hey, when you create the cluster, it's always in a failed state because DHCP doesn't work. And then we'll walk you through how to set up, how to change the IP address. And then when you create the availability group, let me quickly show you how do you create the listener parts. I mean, this is where customers have struggled with. This is where we had a lot of complexities. We show you, hey, you use those dedicated secondary IPs, and then you go and create your availability group listener, and then you have this listener IPs for those availability listener. And then same thing for FCI too. Like in the FCI, I know I'm right on top of the hour. I'll quickly show this couple of screenshots wherein we show you how to create the shared does, how to add them. And then when you start creating the cluster, we'll exactly tell you, hey, once you have the cluster selected, we'll show you, hey, in the cluster network configuration, select this IP from the node 1. And then when you run the install again, you go to the second node and then add the secondary IP for the second node. And that's pretty much it. Yep.
Awesome.
With that, back to you, Anna.
Thanks so much, Rajesh. This has been an awesome show. I've learned so much. Also, I had no idea of this multi-subnet concept, so it's been really educational for me, I think for our viewers as well. Thanks so much, Rajesh and Pam, for being on the show, helping answer questions, show us all these cool demos. The docs look awesome, so I'm going to have to go check those out. Reminder to viewers to just tag this video because we're going to upload update the description with the docs link. So, just thank you so much for joining us. If you like this episode, go ahead, give it a like, subscribe to our channel, check out our weekly show on Thursdays and Wednesdays, and we hope to see you next time on Data Exposed.
Thank you.
Thanks.